So today's lecture is going to be on unit circle trigonometry. So we have talked about right triangle trigonometry and we did some examples of that, and now we're going to look at the other school of thought on trigonometry, which is the unit circle version of it. And we are going to, so everything about unit circle trigonometry is basically in a standard circle and a circle in standard position. So this is x squared plus y squared equals 1. Okay, so that means that essentially here, I'm sitting, I should have drawn the rest of this in here. This is an angle in standard position. That is not a very straight angle, sorry about that. But we're going to say that this is the x-axis, this is the y-axis, and the vertex of this angle is sitting at the origin, which is at 0, 0. And the circle has a radius of 1, right? So this means that the center is at 0, 0, and this means that the radius is the square root of 1, which is also 1. Okay, so all of our unit circle trigonometry relies on the fact that we're in this circle with a radius of 1. Okay, so if that's the case, right, then this is a radii, right? This is an R, and this is an R. So both of these, when they hit this, has a length of 1, okay? So this point over here corresponds to the point 1, 0. So the way that we want to kind of think about unit circle trigonometry is that basically we have, it's kind of like we have, see this little picture I've drawn here? It's not very straight, sorry. But it's, think of it as I'm basically wrapping my number line around the outside of the circle in a positive direction. So when I'm positive, right, I'm going in this way, or if I'm dealing with a negative angle, then I want to think of it as wrapping the number line going backwards, okay? So basically the real number 0 in our new function is, so let's write a table down here. So our real number, if it's 0, it corresponds to this point over here, which is 1, 0, okay? So another place that I can figure out is, right, now we know our radian measures, so essentially this point up here, this is pi over 2, if you remember, hopefully you do, because the whole way over here is pi, so halfway between it is pi over 2. And if the real number is pi over 2, then that coordinates with this point here, right? And if this is, again, the radius, because it's a radius inside the circle, a radius goes from the center to the outside in a radius of 1, this also has a radius of 1. So this point, right, if I wanted to write it in xy coordinate, it doesn't go anywhere, so my x is 0, it's a y-intercept, right? And my y coordinate is 1, so that goes with the point 0, 1, okay? So I just mentioned pi is over here, right? So this is pi, so the real number then, pi, goes with this point over here. So this one was 1, 0. Now imagine, I'm sorry, I should have made that straighter like that. It should be 1, 0. This one over here, I'm going -1 because again, this is a radius, so it's 1 unit. It's going left 1, and then it's sitting on the x-axis, so the x-coordinate is 0. So pi corresponds with 0, -1. And then straight down here, right, halfway between pi, and this would also be 2 pi over here. So both 0 and 2 pi correspond with the same point here, right? So it still lands you on 1, 0 because you just keep going around. But let's talk about this point down here, which is 3 pi over 2, halfway between pi and 2 pi. So that one is not going anywhere. It's on the y-axis, so that means my x-coordinate is 0. Oops, I wrote this backwards. I'm really sorry. This is -1, 0, right? Okay, so I'm going -1 this way, and then I'm staying on there. So this one is actually 0, -1. Okay, so 3 pi over 2 corresponds with 0, -1. So basically, these are the points that they correspond to. Now, if I consider, so now this kind of, the the right triangle trigonometry does come into play here. So if I wanted to figure out what my xy was, okay, so let me drop in here a right triangle. Now we do know that that S, the arc length, right, like this length here, is equal to r times theta. That's from the previous, right? Now in this particular case, in our unit circle, my r is always 1. So essentially S is equal to theta, okay? So that's kind of a nice thing. Now what does that mean for us? Okay, so here's my circle. Let me draw in a better, I'll try to make it a little bit better than the last one. Okay, so if this is my, let's just say that this is my theta here, and this is my point here. If I drop in this, essentially, I dropped in a perpendicular to the x-axis going through this point, okay? So in this particular case, if this is my x and this is my y, let's think about our right triangle things, right? So for instance, the sine of theta would be equal to the opposite side, right, over the, so this is equal to opposite over hypotenuse, right, in right triangle trigonometry. Now, in this particular case, my hypotenuse is 1, and it doesn't matter where I make my, my point, because if I drop this down, this hypotenuse is always going to be the longest piece, and it'll connect. It'll connect to the circle, so it'll always be 1 unit. So really, my sine of theta is really equal to the opposite side. Now the opposite side here, the length of the opposite side is this vertical distance between essentially the x-axis and here. And that is really, right, the y-coordinate. So in unit circle trigonometry, y is equal to the sine of theta, okay? So let's think about now cosine. So the cosine of theta is equal to the adjacent side divided by the hypotenuse. So once again, my hypotenuse is 1, so I know that my cosine of theta is just equal to the adjacent side. The definition of trig functions are essentially, we're going to let theta be a real number and we're going to let xy be a point on the unit circle. Okay, so then we can think of it as, we know that x is equal to cosine of theta, and we now know that y is equal to the sine of theta. And then we can also think about tangent of theta. Okay, so let's come back up here to our unit circle. Tangent of theta in our right triangle trigonometry was really the opposite side over the adjacent side. In this case, this is y over x, which can also be thought of as sine of theta over cosine theta, right? So there's all these different ways to think about, right, the tangent of theta, and cosine and sine. So we kind of go between opposite over adjacent and x and y, okay? All right, so that means that then my reciprocals over here, right, the reciprocal of cosine of theta is secant of theta. So that means that that is really 1 over x, right, the reciprocal of this. Or we can think of it as 1 over cosine of theta, is also an alternative way of thinking of it. And cosecant of theta is equal to 1 over y, or we can think of it as 1 over the sine of theta. And then cotangent of theta, which is equal to the reciprocal of tangent of theta, can be thought of as x over y, or we can think of it as cosine of theta over the sine of theta. Okay, so this is how we kind of think about it this way. Now from this definition, remember we have a right triangle here, right? So since we have a right triangle here, and I know that I can use the Pythagorean theorem when I have a right triangle, and normally I would have essentially, if I thought of this as x and y here, then my Pythagorean theorem is essentially my unit circle, right? It's x squared plus y squared equals 1. I can use that. And from this definition, where x is the cosine of theta and y is the sine of theta, then I can think of it as sine squared theta, really this is my y squared, plus cosine squared theta, this is my x squared, is equal to 1. So we have our first trig identity here, okay? So we have, this is all things, we're kind of like placing our right triangle trigonometry into our unit circle trigonometry. So when I think of the cosine or the sine of some value here, like if I wanted the, you know, this was my point here, that's a terrible straight line, I apologize again, then my cosine and sine would be whatever xy is here, right? Like if I knew that this was the point 3/5 and 4/5, then that would mean that my cosine of theta is 3/5 and my sine of theta is 4/5. Okay? Okay, so let's talk about some special angles. We kind of touched on them in the other lecture on right triangle trigonometry. So the easiest one to kind of start talking about are 45-degree angles. Okay, so I'm going to put my, it's a good thing I never went into art, right? Okay, so we're going to, there's my x, and there's my y. Okay, and I'm going to break this basically into equal pieces, into, I'm thinking 45-degree angles, so that means I'm going to cut this one directly in half because I know that this one here is 90, and then I'll do the same thing over here, approximately. Okay. Here and here. Now something I don't think that I've necessarily talked about yet is a reference angle. Before I get to that, let's actually label these. So this is 0. If this is 45 degrees, then 45 degrees computed to radians is pi over 4. So straight up, right, is really, if I go another 45 degrees here, that would be like 2 pi over 4, which is the same thing as pi over 2, right? And then over here, I go another 45 degrees. So every time I go 45 degrees, it adds me another level. So this was 2 pi over 3, or 2 pi over 4, I'm sorry. This one would be 3 pi over 4, okay? Also 135 degrees. And then when I come over here, this would be 4 pi over 4, which would also simplify to pi, right? So I kind of think of it like that. And then this one down here going another 45 degrees. Remember, 2 pi is all the way around. So this one down here would be 5 pi over 4. This one doesn't simplify. Another pi over 4 moving over here would be 6 pi over 4, which is also 3 pi over 2, which we've already talked about, right? And then this one over here would be 7 pi over 4. This is going in a positive direction. Now, if I was going in the negative direction, this one would be negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi, right? And so this would be, essentially I would take this and wrap it back around this way and call them negative. Okay, so now if we want to think about this, let's just think about our basic pi over 4 here. Okay, so this is our theta value here. Okay, so we know from, if you reflect back on the right triangle trigonometry, right, this is the sine and the cosine, or it's actually the x-coordinate is cosine, and so this one would be, if this is pi over 4, we found that these were the ones that matched, right, where basically this length and this length matched, and we could either call it 1 over root 2, right, or we can call it the square root of 2 over 2, square root of 2 over 2. It's the same exact thing. One is just simplified in a different way, okay? So this is the point, 1 over square root of 2, 1 over square root of 2, because I know x and y are the same, and if I add this squared plus this squared, I do in fact get 1, right? Because I get a half plus a half, which is 1. Okay, so now a reference angle, okay, is basically the angle that is made between the x-axis and an acute angle of the angle. Okay, so this one here, this is my reference angle here. Now, other angles, so this would actually, so this angle here is actually like this whole thing here, right? 3 pi over 4 goes, this is my basically theta, but my reference angle is the angle that it makes, because this is an obtuse angle, right? So I would make my angle here, and that's all, this is 45 degrees again, okay, or pi over 4. So my reference angle is essentially the angle that it makes, the full angle, so like this one here would be 5 pi over 4, but its reference angle is actually, so this is my theta here, is actually this angle here, the 45 degrees that it makes between the x-axis and the circle, okay? So I have 4 different places that have 45 degrees between essentially the x-axis, let me draw that in hard, and the triangle. So I have essentially this one here. Oh, that was a terrible one, I'm sorry. There's theta, there's theta. So these are, my theta in all of these is equal to pi over 4. Now this one up here, it doesn't really, right, these ones that are on the axis don't really have a reference angle because they don't make an acute, because 90 is right sort of like on the board, right? Between 0 and 90 is considered, well, 0 and less than 90 is acute, and then over 190 is 180. So kind of 90 is its own special thing, right? So these don't really have a reference angle. We just have to go from the point on the circle. Okay, so something I want to talk about then. So I know that this over here is this. So that means that the sine of pi over 4, don't ask me why, I always like to start with sine, but sine is pi over 4 is 1 over the square root of 2, or square root of 2 over 2, whichever you prefer. The cosine of pi over 4, because that's x, is the same, 1 over square root of 2, or square root of 2 over 2. And I'll just go one more, tangent. So tangent of pi over 4 is, I can think of it as 1 over the square root of 2 divided by 1 over the square root of 2, which is, in fact, 1, okay? So that's pi over 4. Now, over here, at 3 pi over 4, I already know what these are, right? Because this is the point up here, this is the point 0, 1, I know that my cosine of theta is 0, and my sine of theta is 1, because my cosine is y, or I'm sorry, my cosine is x, and my sine is y, okay? So then I come over here at 3, that's the next one, and I'm going to think about, why did I write tangent first? Let's think about sine first, 3 pi over 4. So let's think about the sine of 3 pi over 4. Now this is a 45 degree angle here, right? And it's a mirror image of this one over here, right? It's exactly, if this was a perfect drawing, these would be exactly symmetric. So essentially they have the same y value, which is 1 over the square root of 2, and then they have the same x value, but this one will be in the negative, right? If you think of us as, this is the first quadrant over here, where x and y are both positive, and over here, I have in my second quadrant, my x is negative and my y is positive. So this one would be negative 1 over the square root of 2, or square root of 2 over 2, whichever one you want to say. So sine of 3 pi over 4 is 1 over root 2, because it's positive, because I'm going up. But my cosine, which is x, my cosine of 3 pi over 4 is negative 1 over the square root of 2. So that means that my tangent is sine over cosine, which would be 1 over the square root of 2 divided by negative 1 over the square root of 2. So this one would be negative 1. Okay? So now this one down here, this also makes a 45-degree angle. So my sine and my cosine essentially should be the same length. It's just about where they're located. So the sine of 5 pi over 4, right? So in my third quadrant over here, right? This is like quadrant number 3. This is quadrant number 2 up here. My x goes negative to get there, and my y goes negative to get here as well. So these will both be negative, but the lengths of the sides are still the same. So the only difference here is I get negative 1 over the square root of 2. My cosine is also negative because it's in the third quadrant, negative 1 over the square root of 2. And my tangent of 5 pi over 4, since these are both negative, essentially I have a negative divided by a negative. Same thing though, it's negative 1. Okay? And then my last one over here, 7 pi over 4, let's write sine of 7 pi over 4, cosine of 7 pi over 4, and tangent of 7 pi over 4. All right, so down here, I'm looking at this point here, and again, my triangle has the same lengths, right? It's just about where they're located and how to get there. So to get to this point, I would go positive x, negative y, right? I'm going to go in positive direction for x and my negative direction for y. So this time my sine is negative because that is my y, negative 1 over the square root of 2, 1 over the square root of 2. And just like my 3 pi over 4 where they were opposite signed, when I put one over the other, I get negative 1, okay? Now, I don't really want you, there's not enough room in my head to memorize these right off the top of my head, but if you notice, okay, when I went around the circle here with my pi's over 4, my 2 pi over 4, when it simplified, it was pi over 2, right? So I already know that sine is 1 in this case and my cosine is 0. My pi, when I simplified 4 pi over 4, I already know this is the point here, negative 1, 0. So my sine would be 0. My cosine would be negative 1. Okay? But all the ones that simplified, we can figure out some other way. So what we notice, I hope I'm trying to point out so you notice, is that everything that's left with 5 pi over, that you have a 4 in the denominator, as long as my fraction in front is in simplest form, they're always going to have these coordinates. It's just about where it is. So if you can figure out like 3 pi over 4, you think, okay, from 0 to pi goes to here, and 3 pi over 4 really is like 3/4 pi. 3/4 is bigger than a half, which would be here, right? So, but smaller than 1. So it would be in the second quadrant. And then if you think the second quadrant to get there, I would go negative, positive. That means that my cosine would be negative and my sine would be positive. So it's only a matter of the sign then. So anything that simplifies and it has pi and 4 in the denominator, right, whatever it is, 11 pi over 4, is always going to be these coordinates, right? It's just about where it is then. So let's say I had, I don't know, let's go backwards because we haven't done that. So let's say negative 3 pi over 4. Where would that land? Okay, so negative 3 pi over 4 would go from 0 to negative pi over here. So negative 3/4, right? That would be bigger than pi over 2 would be right here as negative pi over 2. So I just think of the fraction in front. So this would be like negative a half, and this would be negative 1. So negative 3/4 falls in between there. So that means it would be in the third quadrant where it would be both negative, negative. So I know that this would have a sine value of negative, I'll use square root of 2 over 2 this time, and my cosine value would be negative square root of 2 over 2. So if you can just remember this pi over 4 is 1 over square root of 2, 1 over square root of 2, or if you prefer this one here, it's perfectly fine, then you can just place it in the unit circle and figure out what the rest of them are. Anything that simplifies with 4 in the denominator, we'll end up with these same coordinates. It's just about whether the coordinates are positive or negative. Okay, so then let's do the same thing this time. All right, I'm trying here. Okay, so let's think instead. So we did pi over 4, which is 45-degree angles. So let's talk about 60-degree angles. Now 60 degree is really pi over 3 in radians. So 60 would look about, let's say something like this, okay? So this is pi over 3 here. And then if I go another 60, so I know that 3 pi over 3 is going to be here, right? Because that's pi. So 2 pi over 3 should look like it makes a 60-degree angle over here. So the whole, I know, let's say, we'll say that this is theta. Now this whole angle here, right, this is 60 degrees. This angle here would be 120 degrees, or 2 pi over 3. And this angle here is 180, which is the same thing as 3 pi over 3, which is just pi. So this also breaks it into the same thing down here. So we'll say something that looks approximately like that. And so again, I'm going to have reference angles here. This is going to be essentially a pi over 3 angle here. This will be a pi over 3 angle here. So let's go through here and label them. So this one here is pi over 3. So this one over here is 2 pi over 3. 3 pi over 3 simplifies to pi. I come down here, 3 pi over 3, this would be 4 pi over 3 then. It doesn't simplify. And 5 pi over 3 here, which also does not simplify. 2 pi over 3 here, this is also 0, would be, or 6 pi over 3 would be 2 pi, so it lands right there, okay? Now, if we reflect back here, so this goes with the point. Now, we did a triangle that had a radius of 1. Again, I have a radius of 1 here. And so this would coordinate with the point, right? Go back and look at the other one if you want how we got there. But essentially, in sine of, let's say cosine of, is the adjacent side over here. This is a half, right? And then this is square root of 3 over 2 is the opposite side. You can figure out how I got these from the right triangle trigonometry. So this point here that goes with pi over 3 is a half square root of 3 over 2. Okay, so that means that in this, I'm just going to do sine, cosine, and tangent again. So the sine of pi over 3 is, it goes with this one, is the square root of 3 over 2. The cosine of pi over 3 goes with the x-coordinate, which is a half. And the tangent of pi over 3 is sine over cosine, so that would be the square root of 3 over 2 divided by a half, and this ends up being just the square root of 3 when I simplify it. Now, when it comes to these values, I really want you to remember just the sine and the cosine because you can build tangent. If you can remember sine over cosine and sine and cosine, then tangent is just sine over cosine, so you can just figure that one out. So you don't have to memorize that one, right? You can just figure out that one. But the better you are at knowing these values, the easier trigonometry is going to be for you, okay? So now we come over here to 2 pi over 3. Again, my reference angle right here, right? So this is actually the angle 120, but my reference angle is actually this angle right here, which makes my 60-degree angle with the x-axis. So this one has, now it's just like the other one, right? So this was where my x value, it's the same triangle, it's just in a different coordinate, right? So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant, right? So This one over here is going to be negative as my cosine because I'm going to go negative x value. Y value is positive, so that means my sine is positive. So that means this one goes with negative 1/2 square root of 3 over 2. So that means that the sine of 2 pi over 3 would be positive 3 pi over 3 square root of 3 over 2. My cosine would be negative 1/2. And you can figure out tangent from there. Now, pi, I already know. 4 pi over 3 down here, right? This is my reference angle right here. Well, this is a terrible drawing because it really should look like these should line up basically on top of each other. But it's the same triangle once again. So this point is in the third quadrant where everything is negative. So it would have the coordinates negative 1/2, negative square root of 3 over 2, which means that the sine of 4 pi over 3 is negative square root of 3 over 2. And my cosine at 4 pi over 3 would be negative 1/2. Now in this particular case, right, when I go to get tangent here, because I have a positive divided by a negative, I'm going to get a negative tangent. Here, because I have both negatives, a negative divided by a negative is going to give me a positive tangent. So over here, this one, same exact triangle once again, right? So my point that goes with this would then be positive x, 1/2, negative y, negative square root of 3 over 2. So they all have the exact same, so anything that simplifies with a 3 in the denominator is always going to have some version of 1/2 square root of 3 over 2. It's just about where it lies in our quadrants, right? And so there's a little moniker here that goes with it. So if we think of, let me just draw a little circle down here. Okay. So if I think of my quadrants here as 1, 2, 3, 4, then this one, I want to think of it as all students take calculus, okay? This is my moniker. If you have another one, use it. Okay, what that means, this is essentially my what are positive in each coordinates. So in the first one, all trig values are positive. In the second quadrant, S, so that means sine is positive in the second coordinate. And so that would also mean that cosecant, because it's built from 1 over sine, would also be positive. In the third quadrant, only t, my tangent, or my cotangent, because also goes with reciprocal, would be positive. And in the fourth quadrant, I cannot speak today, quadrant, I have c, which is calculus, or for calculus, means cosine is positive, because that's the x value. So that's kind of a little moniker where I remember what trig values are positive in each one. All right, so now based on that, I'm going to quickly, oh, that was a terrible circle, go through here and put in my 30 degrees because that's the other ones that I figured out in my right triangle trigonometry. All right, so there's 30. So that should break it into 3 equal pieces here. And in each quadrant, it should break it into 3 equal pieces. Oh, that one doesn't look equal, but we're going to pretend like it is. There's one. And there's one, there's one, and there's one. So these are all 30 degrees, okay? So this is 0, right? It's 0.1 comma 0. This is pi over 6 because that's my 30 degree angle. And if you remember from that, that's just got the opposite because in the same triangle I have, in a 30, 60, 90 triangle, right? They're in the same triangle. And so basically, these are just the opposite of my pi over 3. In pi over 6, I have 1/2 as my sine, and square root of 3 over 2 is my cosine. So this one up here would be 2 pi over 6, which is also pi over 3, which we've already talked about. We already know that, so that doesn't fall into one I want to talk about right now. This up here would be 3 pi over 6, which is just pi over 2, which we already know the sine and cosine of, so we won't talk about that one again. Over here is 4 pi over 6, which is really 2 pi over 3, which we just discussed, right? So we don't need to talk about that one. So we have this one that's important to us. We already know this one, and this one. Over here is 5 pi over 6. Now that one is simplified, so we do need to talk about this one. right? Then over here, 6 pi over 6, which is the same thing as pi, which we already know. Over here is 7 pi over 6, right, which we need to talk about. This one down here is 8 pi over 6, which is really 4 pi over 3. We just did that triangle. We just did that value, right? So we don't need to do that one again. 9 pi over 6 is here, which is really 3 pi over 2, which we've already done. And then I come to 10 pi over 6 over here, which simplified is 5 pi over 3, which we've already done. Then I have 11 pi over 6. That one does not simplify, so we need to talk about that. So these three right here, right, these all make 30-degree reference angles. So if this one over here is square root of 3 over 2, 1/2, then that means that this same triangle over here would also have the same coordinates, just now my cosine is negative over here. So this one over here would be negative square root of 3 over 2, 1/2. So let me just write out these real quickly here. So that means that the sine of pi over 6 is 1/2, and the cosine of pi over 6 is square root of 3 over 2 because, right, it's defined as my y is sine and my x is cosine. So I can figure out tangent. I'm not going to do, well, I'll do 1. So tangent of pi over 6 then would be sine over cosine, which is 1 over 1/2 divided by the square root of 3 over 2. And simplifying this would give me 1 over the square root of 3. Or if you really like to rationalize, it would be the square root of 3 over 3. Okay? All right, so then over here, that would mean that the cosine of 5 pi over 6 would be negative square root of 3 over 2. My sine of 5 pi over 6 would be 1/2. Then down here in the third quadrant, they would both be negative. So the point that goes with this is negative square root of 3 over 2, negative 1/2. And so cosine, sine. Okay, over here, this point is positive x, right? So it would be square root of 3 over 2, negative y, negative 1/2. So cosine, sine. All right, so those are all of my trig values. Those are the ones that we really, really need to know. So again, don't try to memorize the whole entire unit circle, but you do want to know the sine and cosine for pi over 6, pi over 3, pi over 4, and then all of the 90s, like pi over 2, pi, negative, or pi over 3, and 2 pi or 0, and so on. So now also, right, I also think that if I went back around, like if I added 5 pi over 6 and I did my full angle, like 5 pi over 6 would be here, right, that angle. But if I went a full way around and landed here, these would be coterminal, right? We talked about that before. Angles, 5 pi over 6 plus 2 pi, which would really be, if I multiply this by 6 over 6 to get, I'd get 5 pi over 6 plus 12 pi over 6, which would be 17 pi over 6. So this coterminal angle would be 17 pi over 6, and it would also have the same sine, cosine.